Hi, I welcome you all for my Java 8 series of videos. In this video, we are going to discuss about Lambda expression. In our earlier video, we got an understanding of what anonymous class is and how we can implement an anonymous class in Java code. We saw a couple of demos to understand more detail about the anonymous inner class as well. In continuation with that demonstration, we can now migrate your anonymous inner class expression into Lambda expression. The idea here is we need to integrate Lambda expression more similar like your anonymous inner class. So how do we achieve anonymous inner class implementations in Lambda expression? We will see that with an abstract understanding in this video. Now, Lambda expressions are anonymous functions. Please be noted. In our earlier video, we were discussing only about anonymous inner class. But now it's all about anonymous functions. Now you can simulate this term called anonymous function to the discussion that we had in the initial video of this series called Lambda function or Lambda calculus function. In the Lambda calculus discussion, we actually discussed about the expression that we denote in the Lambda is all in terms of anonymous. Literally, we don't know what's going to happen in the black box, right? And we don't define a name for it. So, more similar pattern of code is what we are going to see here in the Lambda expression as well. Literally, there is going to be no name for the function, and such anonymous functions are technically now called as Lambda expressions in Java 8. Is there any relationship with anonymous inner class? Yes, of course there is a relationship with anonymous inner class because your anonymous inner class code is what we are going to fine tune to an anonymous function. So that's the reason that we have studied more in detail about anonymous inner class so that we can sync here when it comes to the anonymous functions, as we technically call it as a Lambda expression. So it is a way of representing a function actually. Lambda expressions are representing your functional programming style. Functional programming style of code can be achieved with the help of Lambda expression, and to follow with the Lambda expression, you actually migrate the piece of code from your anonymous inner class to your anonymous function. Now you will instantiate interface with a single method. Your Lambda expressions will instantiate an interfaces with a single method. So what does it mean? You will work with Lambda expression only with interfaces here, unlike your anonymous inner class. You can create an anonymous inner class block of code with the help of interface or with the help of abstract class or with the help of class itself. But when it comes to a Lambda expression, that is your anonymous function definition, you have to refer your interface alone. And that interface must carry a single abstract method in it. There can be only one abstract method. The rule says that your anonymous function declarations can happen based on the instantiation of the interface. Obviously, we are not going to instantiate, but that's the representation of your anonymous function, like how we do it in the anonymous inner class. We technically don't create an instance for interface there, but that's just a template which helps you to create an anonymous inner class. Similarly here, we have anonymous function which again helps you to simulate an template like instantiation of an interface where the interface carries a single abstract method in it. Now, what exactly happens by using this anonymous function? What's the major goal? The major goal is to replace your verbose class declarations. So what I mean by verbose is you keep writing too many lines of code in class declaration, which you can replace it with limited number of codes with the help of anonymous function. If you take the previous demonstration that we have seen in the earlier videos, we started to create a music class and then we converted that music class to an anonymous class. Now this anonymous class is further going to get converted to an anonymous function so that you end up writing minimal lines of code rather than verbose class declaration code. Now there is a way to create a set of function composition methods as well. I think this we have seen even in the Lambda calculus video session in the beginning of this video series. Now what happens in the function composition methods? So what do we mean by composition method is one function will be made up of another function. Meaning is one function will be argumented to another function and that function will produce another output of a function. So it might look like this. You have f of x where that function is forwarded to g of the parameter and the g of parameter will ultimately end by giving you the result for h of x. So function composition is also possible here in the lambda expression. Meaning is you can chain your anonymous function to any inter depth of level. You can chain multiple anonymous functions template into the chain of depth. Meaning is like g of x is one function and that in turn chains with f of x and finally it produces another h of x. So function composition is an operation that takes two functions like f and g and produces another function called h. So that setup of composition methods can be implemented here in the anonymous function. So these are the characteristics of lambda expressions. Lambda expressions are anonymous functions, number one. It is instantiating the interface template with a single abstract method in it. Your code of the anonymous function will be more similar to the code of your anonymous inner class. So that's why here they are referring to an interface. Anonymous function can be implemented only with the help of interface which carries a single abstract method in it, SAM. And the third characteristic of lambda expression is to replace more verbose class declaration. Unwanted code can be eliminated or redundant code can be eliminated or even to say boilerplate code can be eliminated when it comes to the anonymous function template. And it also supports the function composition in it. You can keep chaining your anonymous function to any level. We will see more of demonstration so that you will understand all these characteristics more lively. Now, there is a new term called functional interface. So far we were discussing about functional programming, but now on we are going to use a term called functional interface. Now what this functional interface is all about? A functional interface is an interface which carries a single abstract method in it. Till Java 7, okay, till the version of Java 7, any function which carries a single abstract method in it, such interfaces are called as functional interface. I mean to say here an interface which carries a single abstract method in it will be termed like a functional interface. But technically we haven't represented any interface till Java 7 as a functional interface, but we use this term called single abstract method even in Java 6 and Java 7. The reason is a function which carries only one abstract method in it is technically called as a single abstract method. So the rule for functional interface henceforth is an interface should carry a single abstract method in it. Functional interfaces included in Java libraries. There are predefined functional interfaces are included in the Java libraries and they are like, for example, runnable, callable, comparator, timer task. All these are some instances of functional interfaces. So if you take a runnable interface, as we saw in the demo of our earlier video, I implemented the runnable interface. How many abstract methods were there in the runnable interface? Only one abstract method. Meaning is what? Runnable interface is contributing for a single abstract method structure. So which runnable interface are now technically called as functional interfaces from the version of Java 8. Callable is another example of functional interface. Comparator is another example of functional interface. So likewise, there are n number of predefined functional interfaces are there. And more interestingly, you also have a dedicated library for predefined functional interface, which is called as a general purpose functional interfaces, that we will discuss more in detail in the later video. Now, prior to Java SE 8, that is before the version of Java 8, it was called as a single abstract method types. A functional, an interface which carries a single abstract method in it will be known as SAM types. Shortly it is called as a SAM. But now on, we will technically use a term called functional interface. So SAM interfaces are now called as functional interfaces in Java 8. I'm again stressing it. SAM means single abstract method. The single abstract method interfaces are now called as functional interfaces in Java 8 onwards. So even in Java 9 or 10 or 13, we still use this functional interfaces because Lambda is implemented starting from the Java 8. So to achieve a Lambda expression code, we need to understand the functional interface, because from the functional interface only you will derive the syntax of Lambda expression. Great. So where to use Lambda expressions? The important note, Lambda expressions can only appear in places where they will be assigned to a variable whose type is functional interface. Very clearly mentioned, as I have stated in the earlier slide itself. You can use Lambda expression only to a variable of type functional interface. So you can create a Lambda expression code and assign it to a variable. That's what we discussed in the functional programming, right? In a functional programming characteristics, you will ensure when to say a functional programming, when you can assign a function to a variable, when you can assign a function as a return type from a function, or when you can assign a function as an argument to another function. By all these means, you can call it as a functional programming. Such standard is applicable here in Java 8 because Java 8 is going to follow the functional programming standard via Lambda expression. So this Lambda expression can be assigned to a variable. Lambda expression can be passed as an argument to another function. Lambda expression can be returned as a return type from another function. But all these are possible only when their target type is functional interface. Their target type variable should be of functional interface type so that you can refer the Lambda expression in it. I'll show you a code shortly so that you can actually understand rather than imagining how that template would look like. Now, you want a single instance of an inner class that implements interface. This statement we already discussed much in detail in the earlier videos when we were discussing about the anonymous inner class. If you want such single instance of anonymous inner class representation here, then obviously you can go for your Lambda expressions. The expected type must be an interface that has exactly one abstract method, that is single abstract method. If you have this rule, then you can achieve this Lambda expression. Now if you look at here, the expression syntax, you can understand more clearly what I was trying to emulate from the abstractness of what we have seen so far on the slides. Now here there is a runnable variable called R, and I've defined some weird syntaxes. What is this syntax is all about? This syntax is what we call it as Lambda expression syntax. Please be noted, I'm highlighting here. The highlighted text is what we call it as Lambda expression. Okay, that's great. Now it's a one-liner of statement. Seems to be pretty simple, right? Now let's decode this expression. Now when I'm trying to decode, let me understand what this parenthesis refers to. This parenthesis refers to a method signature. Okay, but what is the name of this method? That's the key here The key point here is it doesn't carry a name in it. So lambda expressions are none other than anonymous function. You only see a method signature there which takes the parameter in it. It's actually no parameter because it refers to the run method of the runnable interface abstract method. Actually, I'm giving the definition for that run method here. The method signature, what you see here, is representing the run method of your runnable interface. We don't use that run term here because it's anonymous, right? The anonymous method signature is defined, and for that method, you're defining a definition, method implementation. And this method implementation and the method signature will be integrated with the help of this symbol called lambda operator or arrow token. Lambda operator or arrow token. There is a meaning. Now, if you recall your lambda calculus, in lambda calculus, if you recall, I used the lambda expression like lambda x dot notation, and then we used m. M represents what? The reference to your functional expression. Similarly here, the lambda x is none other than like a method signature. The dot notation is replaced with the help of an arrow token or a lambda operator, it is called as. And your m reference, which is like x plus y or x plus 1, the expression what we have defined there for the lambda function or lambda calculus function. Similarly here, you have the method expression or the method implementation. You're actually defining the method, the run method implementation here, and it's a one-liner statement. If you wanted to write multiple lines for it, yes, of course you can do it. So ultimately, if you look at the entire expressions decoding, it's pretty simple to understand that you have a method signature in it, you have the method implementation, and they both are separated to give you a practical understanding of the snippet with the help of arrow token or lambda operator. Every programming language like Python, JavaScript, all these languages do have the lambda expression, and they have a different symbol to denote. Python has a different symbol to denote the lambda expressions, that is your implementations and the method signature will be separated with a unique symbol. JavaScript will use an unique symbol, like which Java is using a unique symbol here, which is hyphen and then greater than symbol. Hyphen and greater than symbol combined is what we are going to call it as an arrow token or a lambda operator. So by this way, you actually see that your verbose class declaration got reduced to one liner of statement. And this is obviously an anonymous implementation and recognized as a function. So we call it as an anonymous function, and technically in Java 8 it is called as a lambda expression. What are the different ways to write lambdas? This is the last abstract slide that we are going to discuss, and then we will go on with the demonstration. Different ways of writing lambdas are one-liner lambda expression. That's which I was briefing right now. This is a one-liner statement. But you can also have multi-liner lambda expression. By using open and close curly braces, you can embrace the multiple lines with the open and close curly braces, more similar like your anonymous class block, anonymous inner class block. Lambda expressions with arguments. Okay, you can have it with arguments. If you see the previous line of code, this run method doesn't take any argument. Practically run method never take any input. So you can have a function which takes an input also. Okay, that means a function with argument, a lambda expression, anonymous function with argument. Lambda expression with argument with type inference. So what is the type inference? Technically we will see in the later videos because it's going to be too early to understand those terminology. The next is lambda expression with arguments and return type also. If you look at the previous line, the runnable implementation, no input, no return. It just takes a no argumented function signature and then you just print the statement. That's all you do. You never return any value from there. But you can even write a Lambda expression by taking in some argument, and you can give some return also. So the different ways to write a Lambda expressions are one-liner, multi-liner, with argument with type inference, and with argument and return type also. We will experience all these more practically. There are loads of demos that I'm going to show you, so it will be more interesting. As many number of demos as possible, I'll try to come up with more practical and more interesting kind of demos so that you'll have more exposure on Lambda expressions. So the next video, I'm going to discuss about Lambda expression demonstration. So I'm going to give you a practical understanding of how a Lambda expression is going to get executed in Java 8 version. Thank you.